Okay, example B says write down the equation of the line which is perpendicular to the known line and the unknown line passes through the point -4, 5. So again, we've got two lines in the question, one we know and then we've an unknown line. So the known line has the equation y minus 2/3 x is equal to 6. The unknown line goes through the point -4, 5. And what we want to do is get the equation of the unknown line. Now, to get the equation of any line, you need to know its gradient and you need to know the y-intercept. So let's try and get its gradient first. So we go over to the known line. Now we can't get the gradient of the known line yet because y is not by itself. Remember, the equation of a straight line must be such that y is by itself, it's positive, and it has no visible coefficient. So at the minute y is positive, has no visible coefficient, but it's not by itself. We've got to move the -2/3 x to the other side, and then we change its sign. So we're going to get y equals 6, and then move -2/3 x over. It's going to be +2/3 x. So now that y is by itself, and it's positive, and it has no visible coefficient, we now look at the coefficient of x, and that gives us the gradient. So the coefficient of x is 2/3, so that is the gradient of the known line. Now, these two lines are perpendicular, so to get the gradient for the unknown line, we have to flip the numerator and denominator of the gradient that we know. So it's now going to be 3/2, and then we change its sign, so it now becomes negative. So we've now got the gradient for the unknown line. Now we need to get the y-intercept for the unknown line. Now the problem again here is that the x-coordinate is not 0. So because the x-coordinate of the point isn't 0, this point does not lie on the y-axis. And that means that 5 is not the y-intercept. So the way we have to get the y-intercept now is by subbing the point and the gradient for the unknown line into the general equation of a straight line. So let's get our y-intercept. So we write down general equation of a straight line, y equals mx plus c. And we're now going to sub the point and the gradient into it. So we replace y with the y-coordinate of the point, 5. That's equal to, the gradient is -3/2, so we replace m with that, and I would put brackets around it because we've just subbed in a negative. We replace x with the x-coordinate of the point, that's -4, again put it in brackets because we're subbing in a negative, and it's also got a coefficient, and then plus c. So we're going to copy down our 5. We're multiplying two negatives, so we're going to get a positive. You could type it into your calculator, 3/2 times 4, or 2 down here cancels with 4 on the top line, so that's going to give us 6. So -3/2 multiplied by -4 is going to give us +6, and then that's plus c. Move your 6 to the other side, so it becomes 5 minus 6, which is going to give us -1, and that's equal to plus c. So we've now worked out the y-intercept. So the final thing then is to get the equation. So write down the general equation, y equals mx plus c, and then we're just going to replace the gradient and the y-intercept with their values. So our final answer then, y equals, so the gradient is minus 3 over 2. Then that's being multiplied by x. And then the y-intercept plus c is just negative 1. And that is our answer for part B. Again, just to stress, the difference between what we're doing today and what we did in the previous days is that the unknown line goes through a point that does not have an x coordinate of 0. So because the x coordinate isn't 0, that means the y coordinate is not the y-intercept. So you have to sub the point and the gradient for the unknown line into the general equation of a straight line to get the y-intercept, and then write down our equation.